Good afternoon, everyone. Thanks for joining this CSA Triangle Chapter virtual session. This is the second time we are doing the virtual session this year. In general, we do in-person meetups every month on third Thursday, either at Red Hat Tower in downtown Raleigh or in Varani's office in Morrisville, RTP. So today we have two speakers. Uh, each of them will uh, discuss or present in their areas of expertise. First, Kenneth Peoples, Principal Cybersecurity Architect, Red Hat, will going to talk about scaling the team threat hunting with Kestrel as a service. If you have any questions, please type them in the chat window so that Kenny can address them either during his presentation or after his. And then Pankaj Telang going to talk about how to apply data science and machine learning techniques for detecting security vulnerabilities or threats in software supply chain. He will start at 12:30. With that, I'll hand over to Kenny. Kenny, please take it over. Please introduce yourself and take us through your presentation today. Thank you, Kenny.
Yeah, thank you so much. Looking forward to presentation today and having this discussion. So I'm going to cover concepts during the presentation, and then I'll go into how you can go and try Kestrel as a service, try some of the threat hunting yourself. And I'll get to just a brief introduction. These two slides are backwards. So I'm Kenny Peoples. I'm a Red Hat principal cybersecurity architect. I focus a lot on zero trust architecture, on AI, and the Kestrel project. It's Kestrel as a service. The Kestrel as a service contains different components, including the Kestrel language, which is a threat hunting language. But I am putting together the Kestrel as a service project for my doctorate, which I'm working on at Colorado State University, and working with, go back to this slide, working with Colorado State University, Open Cybersecurity Alliance, and I have a Red Hat sponsor. So the doctorate I'm working on is split into two pieces, a practicum as well, which is the Kestrel as a service project, as well as the dissertation defense. So the project and the paper. But the main thing that I want us to think about while we're looking at Kestrel as a service and looking at threat hunting is thinking more of the sophisticated attacks, the 20% that may be lingering out there in the shadows that a security operations center, other tools may not find immediately that fall into the 80%. So, as I have here in the quote, we need to make sure we're looking at the 20%, and that may be more, maybe less, of course. But that's why we want to look at threat hunting and a threat hunting language, how we can do the threat detection. So, one of the items before I move on and dive deeper into it, out on the Red Hat research site, there's something called Red Hat Research Quarterly. And a lot of what I'm going over right now was just published last month in the Red Hat Research Quarterly. And so this is the link for it. And there's a lot of other interesting content out in the magazine. And I'll drop that in here real quick. So feel free to take a look and provide any feedback, or if you have any questions, let me know. So let's keep going. So I know I only have 30 minutes, so I'm going to speed up a little bit here. With this diagram I put together, the whole focus that I have on this project and that you should think about with the threat hunting language and a team collaborative threat hunting environment is the detect outcome here for an incident. And that's where Kestrel as a service comes into to play, in that we want to decrease the mean time to detect. And we want to make sure that um, if we decrease that mean time to detect, that means we're also impacting, decreasing the amount of time it takes to respond and recover as well. So when we look at our threat intelligence versus our threat hunting, I see a lot of the threat intelligence as that 80% are evidence based um, intelligence with what may have happened on attempted or successful intrusions. And we're looking at the threat hunting where the threat intelligence ends and the threat hunting begins. So we're looking at different hypotheses or indicators, looking at triggers so that we can have an investigation and we can have a response. And so with Kestrel as a service, there are multiple components, and I'm going to go through the different deployment models in a minute. But the main takeaway here, because that mean time to detect, we want to move from a single threat hunter to a team of threat hunters, and we want to share hunt steps. We want to share some of what the bad actors' techniques and procedures may be. So we want to move from that single threat hunter to the multiple and have a crowd sharing is really what we want to get to. And so some of the components that enable us to do that is the Kestrel language, the Kestrel analytics, having this in a container environment, having some additional community projects like Open Command and Control and Stick Shifter and Jupyter Hub running on Kubernetes. And that, of course, can be running on different infrastructure like Ubuntu, Red Hat. We can have it on bare metal. We can have it on the cloud or in a hypervisor locally. The other two components listed here, Ansible Core. With Ansible, the automation, we want to be able to deploy Kestrel as a service, but we also want to be able to have threat hunting with Ansible within the hunt steps. So we'll get to a graphic in a minute. If we look at a hunt book, you can think of all the different steps for a hunt where we're trying to test our hypothesis. We can have that hunt step be based on a data source through Stick Shifter for patterns and observations, or we could be using Ansible, an Ansible playbook. We could be using AI and using something like prompts from ChatGPT. So Kestrel, the Kestrel language, when I just say Kestrel, I'm meaning the Kestrel language. This was a project that started out at ARFL and DARPA, includes the language and the runtime, but this allows us to do hypothesis development, have that open source language, and be able to simplify a hunt and do collaboration. So the sharing portion, being able to share hunt steps with a team and have that crowd hunting. So the Kestrel language, Kestrel analytics, those are part of what I call Kestrel as a service, because that is the team threat hunting environment. So when I was thinking of how can we make the team threat hunting environment, uh, I we can do this in um, a virtual environment by itself and have a container running with all the different components. But that wouldn't give all the capabilities that I wanted and wanted to be able to prove on improving the mean time to detect. So, of course, using Kubernetes or even using Red Hat OpenShift. I know everybody loves Red Hat, right? And loves OpenShift. But having the open source project and a commercial enterprise um, product like OpenShift, I wanted to make sure that it could run in development, production, and an enterprise production environment. And so Kubernetes is what I wanted to base the project on for deployment. And um, one of the features, and you'll see this, I have a reference to Black Hat. There's a Black Hat project presentation that was done with StickShifter and Kestrel and OpenC2. And I have a link for that in here. And Shankar probably, if he hasn't already, will share the presentation out with everyone, and you'll have the links. But the key to StickShifter is multiple data sources where I can look at a pattern and have an observation that I can work off of. So Jupyter Hub is very nice in that I can have these Jupyter notebooks running and they can be shared. I can control access. It's a multi-user environment, and I can control access to those hump books. And I can also provide multiple hunt books, Jupyter based hunt books to a team of folks. So this should help show how our mean time to detect would improve. As I said a minute ago, the Kestrel language and runtime, those are the two main components. So when we look at the Kestrel language and runtime, the two takeaways from that are hunters want to talk about what to hunt, and the Kestrel runtime figures out how to run that hunt. So this is taking the human knowledge and turning it into that language that can be executed and expanded upon. But that interpreter for Kestrel takes that language that's built in the notebook and executes it. And I'm going to show a quick demo on that. Now, some of these I am going to be going quick because there's like 30 slides, like I mentioned a minute ago. So I'm not going to dive deep into all the concepts because I want to show you where you can go get the container and download it so you can get the language and also be able to deploy it in Minikube or full Kubernetes. But what I want to show here, and with this diagram, this is showing I have a threat hunt hypothesis that I see some behavior, bad behavior that may be occurring, some kind of process, etc. And I'm going to create these hunt steps for a hunt flow, and I can fork these. I can do different things with these hunt steps. and even include AI and automation within those hunt steps. So not just looking at centralized log server or some of those logging data sources, but some others as well. So uh, when we're talking about these hunt books, that's what's being built and executed in Kestrel as a service. So looking at the concepts, looking at mean time to detect, what I'm trying to do with Kestrel as a service, it is all tied around crowd hunting. So we want to hunt fast. We want to make sure that we can reuse these hunt flows and have reusable, smaller hunt flows, hunt steps that can be shared. And I can do that in a team environment. So it's all centered around crowd hunting. So as I said before, there's a Kestrel language, and that's a way for me to express what am I hunting. And then for the runtime, the interpreter, that's going to compile that language and it's going to execute those steps. And this language is extensible, and it's out on the Open Cybersecurity Alliance, so you can get to the code and be able to try it out yourself. And so you can come back and read a little more detail on here. But I really wanted to get down to some of the meat here before I ran out of time. So when we look at the development and the deployment, over on the right-hand side, we have our development. So out on Open Cybersecurity Alliance on GitHub, we have Kestrel as a service, which I have built with different deployment models in mind, and have Ansible, along with Vagrant, be able to deploy a environment, a team environment, and include the language, the analytics, some community hunt books, and I'm going to show you where those are located. But have all the development on that GitHub or those GitHub repositories, the main one being Kestrel as a service, and being able to create the container that has those components, has the tutorial, is really easy to go and learn the Kestrel language, and then have that one container be able to be deployed over on the right-hand side. So the different deployment models, we have the container, so an individual threat hunter, I just want to go try out a hunt flow. I can go run that in Docker. I can run it in Python. I can run it in Podman Desktop. I can do any kind of development I want. And then in Minikube, I can stand up a single node Kubernetes, and all the components can be deployed for me. So that means Jupyter Hub, that means Keycloak, some other components, the container, the settings for Jupyter Hub, so forth. I can deploy all that easily, and I have a test environment for a team of threat hunters. So I can have those hunt books shared. I can stop hunting, come back, start the hunting again, and I can share it with my team of 5 or so threat hunters. But then I also, the next deployment model, I can deploy to a full cluster for Kubernetes for a production environment, or I can also deploy to Red Hat OpenShift. So one of the folks that I work with on Kestrel as a service, his name is Shu. He's an IBM security researcher and has done a lot on the Kestrel language, one of the initial researchers. He's working a lot with me on doing the testing on working with IBM customers. And so right now, I am trying to make sure that uh, that OpenShift can use that container too. I have Docker, Podman Desktop, Minikube, full Kubernetes. All those deployment models I've tested and they work well. The Red Hat OpenShift deployment right now, I have to make some changes to the container itself. And I have about 7 minutes, so I want to highlight a couple of the things here. The graphic that you're seeing here, if you go to the steps I have listed and the getting started on the repo, plus the getting started on the slide deck, it will deploy um, Minikube with Ansible and deploy all the components necessary to run Kestrel as a service. And you can also change some of the settings so that it does a full Kubernetes cluster as well. So you can try that out and let me know if you have any issues. But a couple of things here. If you want to use RHEL, also have it used in Ubuntu. But if you want to use RHEL, you can use the no-cost Red Hat developer subscription that allows up to 16 RHEL systems. You can use that instead of Ubuntu. I'm using VS Code, and you can easily make modifications to any of the code. I have the Docker file and I generate the container and put it on Docker Hub. And I'm also using Vagrant and Vagrant Box as well as this Vagrant file customization. But the full Kubernetes cluster is using NFS, the control plane, and the workers. So I'm going to show you in just a second to close this out how you can go and run this container. But these are the steps that I can use to either run it from command line or run it from Podman Desktop. And I can go in and look at the tutorials and learn how to use the Kestrel language. Keep in mind that is just for a single developer. When we get down to this Minikube deployment and the full Kubernetes, that's when you get into the team threat hunting and the settings for Jupyter Hub. They're hard coded for some of the access, but I am going to modify that for what I have with Keycloak for single sign-on. So if you do that full Minikube or full Kubernetes deployment, you're going to see the container platform and see the KAS namespace, and your container platform is going to look similar to that screenshot. When you go to CAS, you're going to either choose a minimal environment or the Kestrel threat hunting. When you go to Kestrel threat hunting, that's the Jupyter notebook that's shown on the bottom right. And I have the tutorials in that system, in that container. So just real briefly, some of these last slides, there's the hello world, which is in the tutorial. And then there is more advanced examples like this one on finding connected entities. And even this more complex example, that's the Black Cat from 2022, that's included in the tutorial as well. And then we have the AI integration that we just demonstrated at Secure AI Summit. um, last week. I'm sorry, not last week, the week before. Um, and so this shows how to have a chat GPT prompt added as one of the steps. And that allows us to, in our notebook and as part of the Kestrel language, have an open AI API call to look at suspicious activity. And I'm going to be increasing that more. But this also has the sample code in that repo. And so you can go and look at this on the Open Cybersecurity Alliance. And I'm going to pull up the desktop, Podman desktop real quick, and then close us out for our next speaker. But some of what you'll notice is, since I am doing this for my doctorate plus um, working with IBM and Red Hat, there's still a little bit more to be added to CAS, such as the Ansible threat hunting in the step, some more on indicators of behavior, and some more on AI. So, I would love for people to get involved and go to Open Cybersecurity Alliance, look at the code, contribute to it, test it out. Let me know if you run into any issues and I can help. But to close this out, since it's about 12:30, I want to show just a couple of quick things here, and then I'll turn it back over to Shankar. So the first thing I want to show is the repos. Um, Over in the Kestrel Analytics, this is that OpenAI suspicious process ranking. You can look at the code there. But if we go back to this Open Cybersecurity Alliance, you'll see Kestrel, you'll see Stick Shifter within the repos. You'll see Kestrel as a service, Kestrel Analytics. So feel free to go get involved. Would love to have folks involved. Then what I have running here, if you have Minikube, full Kubernetes, or even just the container standalone, when you browse to it, you're going to be pulling up this notebook. Within this notebook, you have Black Hat 22. So that matches the videos. So you can try that out yourself. Plus the tutorials, like the Hello World that I just described. So this talks about some of the terminology, but you'll notice it's executing live. So this step here already executed in a process list. So when you go and look at Black Hat 22 and look at this one, it's already executing as well. So if something happens and you try and run this and you don't see output, then something's wrong with the deployment, because it should execute your Kestrel language steps. So the last thing that I wanted to share here was Podman Desktop. And the way that you can use Podman Desktop is you can go over to your settings, into your registries, and I have it linked to Docker Hub. But what I'm doing is I have this container here, docker.io with kpeoples. I have that CAS container or Kestrel container where you can pull it down and run it. So that's all I did was, for a standalone developer, I'm running that container. But to improve that mean time to detect and the whole theory hypothesis I have, we can improve that mean time to detect all the outcomes from the NIST cybersecurity framework. I can find those incidents faster by using a crowd sharing threat hunting platform like I have here. I'm going to stop there because that's a lot of material, um, and turn it back over to Shankar. So please go out to Open Cybersecurity Alliance. Look at what I have out there. You can look closer at the presentation. You can run the container or deploy to Minikube, full Kubernetes, and then OpenShift when I have some changes to the container. Shankar, I'll turn it over to you, and thanks for allowing me to speak.
Thanks, Kenny. Thanks a lot for your great presentation. Uh, Pankaj, please go ahead and start sharing your screen. So for the folks who joined late, the session is being recorded and it will be uploaded to YouTube CSA channel, um, which I just gave you the link in the chat. And we'll make the slide decks available as well on our LinkedIn group, the Cloud Security Alliance Triangle Chapter LinkedIn group, which I'll post it as well.
Yeah.
So please welcome Pankaj Telang, the principal engineer at Stacklock. Pankaj, I'll let you introduce yourself and walk us through your presentation.
Sounds good. Yeah, thanks, Shankar. So my name is Pankaj Telang. I am a data scientist slash machine learning engineer at Stacklock, and I have been working in the technology industry for about 25 years now. Worked in various roles at Cisco earlier, later on at SAS Institute, and now I'm working for this startup called Stacklock. And I have background in machine learning, AI, and applying machine learning AI to addressing cybersecurity problems. So what I plan to do today is give an overview of applying data science or ML techniques for detecting attacks in supply chain. So as many of us know, software supply chain attacks are on a rise. So there have been several attacks that we have seen just last year. About 60 to 90% of the companies experienced a supply chain attack. There are predictions by Gartner that over 45% of the organizations will see such an attack by 2025, which is almost 3 times higher than what it was in 2021. So there is a sort of a quick acceleration or ramp up in the number of attacks that are happening. And there is also a prediction that these attacks will have big financial consequences. Up to $60 billion will be lost in fighting these attacks by 2025. What you see here on the right-hand side is a comic from XKCD. This is a pretty popular comic which shows the the vulnerability in the supply chain. So if you develop a software somewhere up on the top here, and you make use of an open source package or a software, and that package has several dependencies, transitive dependencies, going down to, let's say, one small project here, which is maintained by one person, who might be overloaded due to the work that person has to do. And of course, this is open source software, so this person may be doing this work for free and may not exercise due diligence in some cases. So if this small project gets compromised, then everything that sits on top of it is automatically compromised, leading to a large scale supply chain attack. So that is what we want to guard against. So let me first walk through the open source development and build activities and talk about how the attacks map to these different activities. So we need to understand who the key players are and what are the key systems that are involved in an open source development effort to be able to understand where these attacks can happen and Once we understand that, then we will know what kind of techniques we can use to detect these attacks and guard against them. So in a typical open source ecosystem, you have a set of contributors that are essentially developers who develop and commit code. The way they commit code into the source code system is by creating what is referred to as a pull request. And there are various kinds of source control systems out there, the most popular being GitHub, but then there is also GitLab, Bitbucket, and so on. Then there is a maintainer, one or more. Maintainer is a person who is responsible for an open source project. And these are the people who review the pull requests. They approve them and they merge the pull request into the source code. The maintainers also are responsible for configuring and setting up triggers in the build system, where the source code is compiled into some artifacts, like, for example, packages, which are then deployed into a distribution platform. The maintainer is also responsible for configuring these packages in the distribution platform. So setting up the details of the package in terms of where the source code of that package lives, versions of the package, other metadata associated with the package is all configured by the maintainer. So maintainer has a lot of responsibility as well as a lot of power, as you can see in this overall ecosystem. So by distribution platform, I mean platforms like NPM, PyPy, crates, and so on. So most of the developers here would be familiar with these. NPM is used for JavaScript packages, PyPy for Python, and so on. So let's look at how such an environment can be attacked by attackers. So the overall intent of the attacker is to inject malicious code somewhere in this ecosystem. So they can inject malicious code in new packages and figure out a way to get users to install those packages. So that is one way of getting malicious code out into the wild. Second way is they can take an existing package and figure out a way to infect that existing package with malicious code. Now, on the left side, when they create a new package, the important thing is to figure out a way to get end users to install or adopt those packages. To do that, there are different techniques that attackers use. One is referred to as starjacking. I'll be describing this in more detail further down. Typo squatting, where a package is named very similar to another package, by which a developer or an end user is tricked into installing it. And then use after free is another sort of interesting technique where if there is an existing company or a project that is renamed, their previously named package or repository in GitHub, for example, might still will not be used because now they have a new name, but the older name can be adopted or hijacked by attackers. And when they do that, then they can place malicious code in that previous name, and then hope that some user will come along and wouldn't know that the package or the company got renamed and download the malicious code. So that is what use after free means here. On the right-hand side, infecting existing packages, what attackers can do is they can essentially inject, or the first thing they can do is simply inject malicious code into the source code. They can do that by contributing a pull request which has malicious code in it, or they can figure out a way to become maintainer by stealing the credentials of the maintainer. So if they can just steal if they can figure out the credentials, if the credentials are weak, or if they can use social engineering techniques to get maintainer to share their credentials, attackers can become maintainers, and once attacker becomes a maintainer, then all the bets are off. The second thing attackers can do is they can compromise the build system. So they can inject malicious code when the package is getting built. They can manipulate the build system. For example, they can change the DNS server that is used by the build system. And instead of using a legitimate distribution platform for packages, they can get the build system to download packages from a compromised deployment platform and essentially inject malicious packages during the build time. They can exploit the build system if it is a shared build system where they can uh, inject the malicious packages in the caches which are shared across the different parts of that build system. And finally, they can inject the malicious package in the repository directly. So for example, if there is a popular package in, let's say, Python in PyPy, they can create a malicious version of that package and uh, upload it in the repository. And the way they can do that is again by stealing the credentials of the maintainer or by exploiting some vulnerabilities that might be present in the distribution platform. And the final way they can do that is they can use a mirror of the repository and deploy the malicious package in the mirror and hope that some users will go to the mirror rather than to the original deployment platform to get that malicious package. So many different ways they can figure out a way to get malicious code out to the end users. So if I just take those attack vectors and line them up, here is how the scenario looks like. So on the left-hand side, on the code base, malicious code can be contributed through PRs, maintainer can be compromised, and the bad actors can commit bad code directly into the code base. The build system can be compromised using the vectors that I described. And finally, malicious actors can upload malicious packages directly into the distribution platform. So what I will do today is talk about data science techniques we can use for some of these attacks. So I will start out with typo squatting attack. So what you see here on the left top is a few examples, and these are real examples of typo squatted packages which have been placed in PyPy repository. So these are Python packages. So the first one, for example, is MumPy. MumPy was very similar to NumPy. So if you are a developer and you are not careful and you type pip install instead of NumPy, you type MumPy, you end up getting a malicious package on your computer, and your computer is infected. So the question becomes, how do we identify whether a given package is a typo squatted package or not? So what you see on the right here is an algorithm which makes use of some of the data-oriented techniques for figuring out whether a package is typo squat. So we have a package X. We want to figure out if it's a typo squat. What we need is a database of all the packages. So this is something you have to build out, assuming this is what you want to implement within your enterprise. So you want a database of all the existing packages. What you will do next is figure out packages that are similarly named as the new package X. The next thing you want to do is compute popularity of those similar packages. So the attackers are always trying to find popular packages, and for the popular packages, they are creating the typo squatted packages. So we intend to find similar packages that are more popular than the package that we are trying to figure out if it is typo squat or not. If we find a more popular package which is similarly named, then it's highly likely that the new package X is a typo squat. Otherwise, it's not. So you can use various measures, like Levenshtein distance is one of such measures which is quite popular for figuring out typo squat attacks, which looks at how many characters are different between the strings of a new package and some other package, like an existing package. And for popularity, you can make use of, let's say, a principal components analysis to compute popularity of the packages based upon features like number of downloads, number of forks in the GitHub repo corresponding to that package, stars, watchers, and so on. So the second attack that I will talk about here is starjacking. So in starjacking attack, what an attacker does is they will create a new package. So here I made up a package name called fast-requests. For the Python developers here, you will be familiar with a package called requests, which is quite popular, which is used for API calls and HTTP calls and so on. So a attacker can create a new package called fast-requests and associate it with the repository of the requests package. So this request package is legit, and the repository corresponding to it is also legit. And you can see the stars forks have pretty large numbers, which means that this is a popular repository. So if you are an end user and you look at this fast requests package in pypy.org webpage, then you will see these numbers and you will start to think that fast-requests is a pretty popular package and should be reliable, so I should go ahead and use it. But it's not, right? So it's just falsely claiming this specific repo to be its source repository. So what you see on the right here is an algorithm for figuring out if a package is starjacking a source repository or not. So you start out with that package that you are trying to figure out if it is starjacking a repo. The first question that you want to ask is whether this package has what is referred to as SIG-store provenance. By SIG-store, what I mean here is there is a very popular open source project called SIG-store, which allows you to create, which allows you to cryptographically sign a set of claims for a package. So for a package, if SIG-store provenance is available, then you know with surety that that package is not a starjacking package, because that package is claiming that specific source repository to be the repository from which that package came. So there is nothing to be done, which means in case of SIG-store provenance, the package is not starjacking the source repository. Now, if the package does not have the SIG-store provenance, then you need to develop some sort of a heuristic to figure out if the package is starjacking or not. And here I have described one such heuristic. So one thing you can do is you can extract tags from the repository, the source repository of that package, and you can extract versions from the distribution platform. You can extract all of the versions and tags and keep them in a database. So here you are just sort of referencing those. And what you can do next is you can see how much they align with each other. So in a common practice, what happens is source code is tagged in the source repository and a version is cut and placed in the distribution platform. So if that is the case, then the tags and the versions, they will line up with respect to timestamp. If they line up, then we know that the package is unlikely to be a starjacking package. But if they don't line up, then it's a situation where the attacker is creating the packages later on after the tags have been placed on the source code. And there is no alignment between the two. So it's very likely that that package is starjacking that specific source repo, in which case you need to investigate that package further before you start using it. Another concept that I will introduce here is reputation graph. So if you look at the open source project and open source communities in general, they have what we refer to as proof of diligence built into them. By proof of diligence, what we mean is the contributions that are accepted by project are verified using several factors, such as whether the contribution is useful or not, what kind of quality is that contribution of, whether that contribution is using appropriate security measures or not. So the contribution, that is the source code, which a contributor or a developer creates, is looked at from various perspectives. So you can imagine that if a very reputed contributor is contributing to a project, then it's likely that the project is also of high quality. So the project's reputation should increase because there is a reputed contributor contributing to the project. And vice versa as well. If there is a new contributor, like let's say a fresh developer who contributes to a very well-known project, then it's likely that that specific developer is also of higher quality. So that specific developer or contributor's reputation should increase. So in short, what we can do is we can model the overall open source ecosystem as a large graph of packages, projects, and contributors. So it might be hard to see this graph here, but in the middle is a repository. On the sides are the different contributors, and the node that is in red color is a package. So you can create a graph and implement a reputation propagation algorithm to propagate reputation throughout this graph and compute a score for each entity. And then these scores can be used for package selection. So for example, this next package has a score of 10. So on a range of 0 to 10, next, which is a NPM package, it's getting perfect score. So you can assume that it is a really, it's a good package that you can adopt and start using. I'm going to run through the rest of the slides here. Malicious commit detection. So let's say you want to figure out if a commit is good or bad. One thing you can do is you can look in the source and run SCA analysis on the source code, but you cannot really do that you cannot do it at scale when you have millions of commits happening on several millions of open source projects. So what you want to do is first do some analysis at a behavior level. So what you can do is for commits, you can look at what are the how many number of lines are added or removed in a typical commit, how many files are added, removed, what kind of sensitive files are modified, what are the typical commit times, and look for commits that are significantly different from normal behavior. Once you do that, then you have a smaller set of commits on which you can do some additional analysis like SCA or manual inspection to see if that set of commits have any malicious code. So going down all the way to the level of figuring out if a given piece of code is malicious or not. How do you do that, right? So how do you know whether a piece of code is good or bad? So again, you can run SCA, and if you are running signature-based SCA, we all know the disadvantages of those. Attackers always figure out ways to defeat the signature-based approaches by writing the code in a different way, by obfuscating the code, and so on. So what you can do is you can make use of a machine learning model to figure out if a piece of code is good or bad. Here is a quick example. We got a typo squatted package called MongoDB, which is running a script called test.js on install. So as soon as you do an installation of this package, attacker is going to, or the installer will run this specific piece of code, which will take your host name and will send it to attacker controlled URL. To detect this, you can extract a set of features, like you can look for installation hooks, you can look for how much code is obfuscated, sensitive strings, and so on. So you can extract the features, you can train a machine learning model, you take the trained model, a new package comes in, you extract the features out of the new package and use the trained model to predict whether the package is good or bad. Now, no presentation is complete without LLMs. So here is my LLM pitch. So we got We can make use of LLMs for figuring out if a code is malicious or not. So you take the source code and you use a prompt. So here I give the entire prompt that you can read. Prompt is telling LLM to check whether the code has any evidence of things like data exfiltration, access to sensitive files, and so on. So you pass this through GPT-4, Code Llama, or any of the other popular LLMs. LLM will be able to tell you whether that piece of code is good or bad. So you can use LLM for figuring out whether a given piece of code in a package is malicious or not. So finally, a quick uh, point on StackLock. So at StackLock, we have been working on developing these algorithms and implementing them in two open source projects. There is one called Minder, which is not something that I touched upon today. The second project is Trusty. That is the one that I spoke about, where I described the various algorithms. You can go to these URLs. The second URL, trustypackage.dev, is the Trusty implementation where you can plug in name of a package. We have implemented several algorithms that I have described here. And what we will report, what Trusty will give you is a score, is a Trusty score for a package. So the higher the score, the more dependable the package is. The lower the score, the more risky the package is to use. And you need to do due diligence before adopting that package. So you can take a look at some of these URLs, and both of these projects are open source. So feel free to go to StackLock GitHub repository and take a look at our source code. If you would like to contribute or have comments, we all welcome those. And that is all that I had for today.
Thanks, Pankaj. If there are any questions, please reach out to the speakers directly, or you can actually make those comments on the LinkedIn page, or try to figure out a way. You can send me an email or reach out to me if there's a question to the speakers, that I can relay those questions to them and maybe connect to you guys directly so that you can exchange or have that follow-up discussion. Thanks a lot, Pankaj. I'll stop the recording now.